Okay, so we're here in Vex EXP. I'm downloading to slot 1. I've opened a program that has been saved as optical test. We have a controller attached to the computer I'm programming on with a USB-C cable, and that controller has been wirelessly connected to a brain on the robot that you see in your lower left-hand corner on the video. Okay, so let's look at the code. So we have a forever loop. We then have a if, else statement. Okay. Each time in the if, we have optical 5 detects red. So if optical 5 detects red, print red. If optical 5 detects green, print green. If optical 5 detects blue, print blue. And then else, print other. So where does this optical 5 come from? Well, before any of this optical sensor will appear, you need to go to the devices menu and add a device. So you click on add device. Let me go ahead and delete it here. Okay, so we add a device, we clicked optical, and then we selected the port that the optical sensor is in. Okay, so let's just do that real quick here. Okay, so it'll look something like this. We just click to select the port and click done, and then it's called optical 5 there. Okay, so so then after the if statement, then each time we're going to print the optical 5 hue in degrees on the console. So these are all on the console. And we'll print a line break after that last one. So let's go ahead and take a look how this works. Okay, we're downloading it to the robot. Okay, so now that you've programmed on Vex a little bit probably, on this Vex system, you'll notice that things don't always behave as you might expect. So let's take a look at what this actually does. So we're going to go ahead and click run. So initially we're detecting green. So if we had an if statement and we said, hey, what are you detecting now? The answer would be green, right? There's nothing in front of the robot currently. But notice that when the optical sensor has a value of around 100, it categorizes that as green. Okay, so if we go ahead and put a blue ball directly in front of it, notice that now it has other. Okay, as the ball gets closer, still other. It's right on top. We get to blue. Okay, so as it goes closer and closer, notice that we get to blue. Okay, so let's go ahead and go to red. So we have red way out here, and you can see that it changes as it would get closer. So if we're driving up, we get very close, and finally it turns to red. So this is an example of how this hue. So basically the firmware on the robot or programming, the underlying programming is converting whatever the sensor is seeing to a number, to an integer, right? And that integer is being interpreted as a color here, in this case, red. Okay, so go ahead, pause the video, just maybe do this initial set of programming here, just to take a look at how things are working. So then let's take a look at the Python code. Okay, this Python code, it's sometimes confusing in the Python code because sometimes we have this these variables that don't seem to be here for any reason. So the Vex code brain precision, Vexel console precision is 0, and then we bring these variables into our function using this global variable. So this is our main function here, def when started 1. That corresponds to this when started right here. And then we have our loop. So while true, and then we have our if statement, while optical _5 dot color is equal to color red. Okay. So we have these things right here. So this is our else if, corresponds to else if here, print screen green, and then notice that it always adds this end part. If usually you don't if you don't want a line break, you need to add this this comma and then end equals and then empty string here between the two double quotation marks. So we have else if optical 5 is equal to color blue, then print blue, else print other, and then we have our print to console, and that's just kind of a fancy print. That's probably not necessary, to be honest with you. And we're printing out the optical 5 hue in degrees. Okay, and then finally we have our wait 5 milliseconds, which seems to just help the Python code function. Okay, so that's our test just to see how the optical sensor works. Now let's take a look in practice. So we're going to go ahead and open up another sample program here. And this is something that I put together. It's not available, so just pause it and recreate it if you want to. Okay, so I'm going to show you an example of something that, first of all, I'm going to show you the example that I tried first. Okay, so this is an example of what I tried first. Okay, so when started, repeat until optical 5 detects red. So this seems like it should work. Okay, so we have a repeat until block. We say this is an if statement, right? Optical 5 detects red. That's our, if optical 5 detects red, it should be true. If not, it should be false, right? So while repeat until optical 5 detects red, and we're looping this, so we're printing not red, right, the whole time, and we're driving forward. And then once it detects red, it's exiting this loop, and then it's printing red, and then it's stopping driving. Okay, so in testing this code, I noticed kind of something strange, and basically this code just didn't work. So, and we'll take a look at why. Okay, so we're downloading the robot, and we're going to go ahead and click run, and nothing happened. Okay, so let's take a look at our console here. We can clear it and then let's run it again. Okay, so immediately this tests as false. Okay, so if we go back to the code on the underlying Python code here, we take a look while not optical 5 dot color, and this is calling the color method in this optical 5 object. Okay, so if we think of, and I'm going to get a little bit deep here for a second. So if we think of this color, this is a class. It's like the cookie cutter. Okay. And an object is like the cookie made from the cookie cutter, so which we can go into later. But basically what happens is this immediately tests this whole thing not. So optical 5 color red tests as true, and we're saying while not optical 5 color red, right? So it should be printing not red, but in fact, it just immediately goes to red, right? It immediately says, hey, it's already detecting red, and then it's going to go. Okay, so let's take the red ball out of the way here, and we're going to run it again. So in this case, we just did our test. We just did our optical sensor test, right? And it tested green right off the bat in the same position. So if we go ahead and run this again, it just goes to red. So none of this ever runs. So this part of the code, basically, this immediately tests as false and this never runs. So this will not work. So let's take a look at code that does work. So if we have this optical sensor here, okay, so let's take a look at the way we can do this. So what we want to do is we want to have the robot move up to the red ball and then stop. That's what we would like it to do. So let's take a look at how we can do that, and it will work. All right, so we know that the way that we first approached it did not work. And we'll talk about why it didn't work in just a second. But let's take a look at a way to do it so it does work. So if we have while started forever, okay, and we bring over this if statement, okay, and we say if optical 5 detects red, then we print red and we break. Okay, so break means that we break out of this forever loop, right, and we go to stop driving. Okay, so basically this will repeat forever until optical 5 detects red. It's going to print red, then it will break, and then it will go to the next line, which is stop driving. Okay, now in the meantime, if this condition, so we have our condition here, if this condition is false, it will go to the else, and the else is to drive forward and print not red. Okay, so we are just thinking about, we're basically creating that until, loop until functionality. We're just doing it ourselves, right? So basically this is going to loop until optical 5 detects red. So let's look at this underlying code here. Okay, so we say if optical 5 color is equal to color red, then print red, okay, and break. Okay, so remember our break is basically we're leaving this loop. So it's going to loop lines 7 through 13 until this break is run. Then it will exit the loop and then run line 14. Okay, so you really need to understand that. So basically, while this is looping, lines 7 through 13 is going to 7 through 13 is going to loop. Okay, it's going to keep looping. Okay, each time. So if this if statement, if optical 5 color is equal to red, if that is false, it will go to the else. The drive will drive forward. It'll print not red, and it will just keep looping. Okay. As soon as optical 5 color is equal to red, it runs lines 9 and 10. At that point, it prints red. It breaks, and the break is a break out of this loop. Okay, so it breaks out of the loop, which is on lines 7 through 13. 7 through 14 because it includes the wait. And then it basically goes to the next line, which is drivetrain stop. Okay, so let's take a look at this. So we're going to go ahead and download this program. Okay, so let's go ahead and run it. Oops. I set up my drivetrain wrong. Let's go ahead and reverse the drivetrain. Okay, so you can see my motors are on the back. I forgot to reverse the drivetrain. Okay, here we go. All right, so we're going to download again. All right, and so basically all we're doing is we just kind of had to look, we tested something out. A lot of times when you use systems like this, the libraries are imperfect. So when you're trying to develop something, you just have to accept it as it is. We don't want to go out and fix the Vex library. We're just trying to use it to get something done. So in this case, we just experiment a little bit and find a way around, a workaround, rather than a fix. Okay, so here we go. So we're going to run it. Okay. And there you see that basically we had not red, not red, not red, not red. Each not red is a loop here. So every time this printed not red, that represents it running this loop. Each not red represents this line getting run, which there's a drive forward in that line, so both ran. And then finally, when it says red, that represents this optical 5 detecting red. It prints red, it clicks break, and then it stopped driving. Let's go ahead and try that again. So let's go ahead and clear it. We'll move back the robot to here. And we'll go ahead and run it again. Okay, so here we go. Okay, it detects red and stops. Now, I'm a curious person, as are you. Okay, so why is this working? Okay, well, in the end, we don't know. I still don't know. If we wanted to open up the library, we could look at the underlying code, but it's just not worth our time. Okay, and basically in this case, this seems to work when it's testing true, but not when it's not. Using the not seems to be problematic. Okay, now we can fix this code, so let's go ahead and I'm just going to this is kind of a side. So if you're looking to just get the optical sensor working, this is your code. So pause the video, take a look at the code. But I'm kind of curious as to why it didn't work. So let's go to we're going to go ahead and open recent, and we'll take a look. So we have this code here should have worked. So we have repeat until optical 5 detects red, and then stop driving. Okay, this is more kind of concise code. So we have while not optical 5.color is equal to color.red. In this case, these two things were suspicious to me because this is a little bit different. So in this case, we're talking about an object calling the color method of that object. In this case, we're using a class and we're representing an attribute of that class, which is red. Okay. So I said, well, that doesn't look super right to me. Okay, there can be some issues with using classes versus objects. Okay, so so basically I said, well, hey, like what if we instantiate this color class into an object? We just make an object, we just use right then, we don't call it anything. So let's go ahead and take a look at that. So basically I just saved this same project. I converted this. So I basically went in and said convert to text project. And then I call it Python glitch. There we go. Okay, and so basically all we need to do in this case to make this work is we just have to instantiate this color object. So basically here, instead of just naming the class, saying, hey, reference the class and the attribute color, we instantiate the class as an object, and we say, hey, like now we have an object and we're referencing the color red, the attribute red, and we're using that in our if statement instead. So let's go ahead and download this to the brain. Okay, so in this case, it's a simple fix. And what I'm kind of demonstrating here is that you know, these programming languages are often kind of arbitrary. You know, it's just people making this stuff up. So if you know, if things don't work and they don't act like you might expect, just be persistent and, you know, maybe look up a couple things, learn a couple things, and you can kind of get things working. So let's go ahead and re-download it and let's go ahead and run it. That's so funny. I keep forgetting to reverse the drivetrain. Okay, I'm going to go ahead and click done, and we're going to download it again. I keep forgetting to reverse my drivetrain because in this case we basically put there's a, you know, we just reversed the Clawbot build and we put the optical sensor on the back, so you have to reverse the drivetrain. And basically this, when you go to the drivetrain, you see that orientation of the motors on the robot. Okay, so we're downloaded again. We're going to go ahead and click run. We're going to take a look. Okay, so let's try this one more time. Let's pull it back. And let's run it again. Here we go. Okay, so there it is. So there's our loop running with our many not reds. Okay, so that's while not. Okay, it's while not, you know, while it doesn't detect red, and this is it detecting red, right? So basically, rather than doing optical 5.color parentheses equals color.red, we basically just instantiate that color class as an object, and then reference the attribute of the object rather than the class. Okay. All right, so that's one way to get that working. Finally, let's go ahead and take a look at a final example here. Okay, and this is just the most simple version. Okay, so this is just the most simple version, and basically this is just starting a Vex Python project, and we have a while true, and then print optical color. Print color .red, and then if optical 5 color equals color.red, print red, wait 1 msec. Okay, so basically in this case, all we're going to do is I just wanted to talk about a little bit about these colors and how they're kind of determined here. So basically, let's go ahead and download and run this. Because if you start to look at this, it might seem kind of odd. So, okay, so we're going to go click run. And so here what we have, whoops, let's stop this for a second. Okay, so basically here we have the first number is what the color of optical 5 is seeing, and the second color is the color that is the color red out of, you know, basically a color object, right? So we create the object, a color object, and we're referencing its attribute red, and basically we're looking to see if it matches. So what we have here is we have the hexadecimal number of the color. Okay, so you'll see now as the robot drives up to the red ball, as it gets closer, you'll notice this number changes for the optical sensor, and finally, once it gets very close, you'll notice that it starts to detect red, and that's when these two hexadecimal numbers are equivalent to each other. Okay, so where do these colors come from? So here we have, in this case, we are looking, and we've detected red, right? So we have this color red, and it's 00FF0000. Okay, so this Vex sensor is using ARGB color. Okay, And so basically it's kind of like hex. It's, they're hexadecimal numbers. So the A is the alpha channel. That's, how opaque it is. Then we have red, then green, then blue. So in this case, we have 0, 0 is the alpha, FF is full red, and then there's 0 green, there's 0 blue and 0 green. Okay, so it basically is 2 alpha numbers. So alpha, it's AA, R is the next two, FF, green is 0, 0, and then, blue is the next one, and then, here we go. So ARGB stands for alpha, red, and blue, green, and it is associated with these pairs of numbers. So when you look at these, values that come out of the Vex optical sensor, so blue would be 0, 0, 0, 0, FF, 0, 0. Green would be all zeros and then FF at the end. Okay, I hope this helps you understand the colors better, and as well as the optical sensor. Best of luck.